My name is Justin Ryburn. I'm the Vice President of Solutions Engineering here at Kentik. I'm going to talk in this session a little bit about container network observability. So taking the last session, if you haven't seen that, go back and watch Ted's talk on cloud. We're going to take that a step further and talk about microservices that are running in containers and how do we observe that network traffic in those containers. So that'll be the purpose of this talk here. Again, if you want a broader background on Kentik and who we are and what we do, go watch one of the previous presentations where we gave a little bit more of a background, but just to kind of set the stage here for what I'm about to talk about, we're ingesting data from a lot of different places in the network for an enterprise network. Specifically, I'm going to talk about containers. We've had other talks where we've talked about other parts of the network. We ingest that data, provide a lot of rich context to it to be able to answer a lot of questions that you may have about your containerized workloads that are running, whether that's in a public cloud environment, in maybe a hosted Kubernetes cluster like an EKS, an AKS, or if you have your own on-prem Kubernetes cluster you've built, we can observe that network traffic as well. The goal of doing that, again, network observability, there was a previous session today where Phil really described what we mean by that. You can go check that out if you want to define the term network observability, but for the sake of this conversation, we're looking to answer questions similar to this, right? Around container networking, I want to know potentially what is consuming all the bandwidth between these various different nodes. What's talking to what? Why are my instances not able to talk? So if I spin up two different microservices of an application, they're running on two different nodes, they're not able to communicate. What's causing that? How do I troubleshoot that? These are some of the types of questions that we hear from our customers that they're struggling with when they move into containerized workloads. Which kind of brings me to this, right? Those of us who kind of came up as classic, I call them classically trained network engineers, network practitioners. We think in terms of things like OSPF, EIGRP, God forbid, spanning tree, these different protocols that we all learned and studied for on a CCIE or a JNCIE, or insert your favorite vendor cert here. Some of those are less relevant in the cloud. The network fundamentals that we all learned are still relevant when it comes to containerized workloads and to the cloud, but you're not going to be troubleshooting an OSPF neighborship. You're not going to be looking at spanning tree. You're going to be having to learn things like Linux namespaces and kernel routing inside of the Linux kernel, CNIs, which stands for Container Network Interface, pods, node pods. I won't go through each one of these, but these are a lot of new constructs and new terms that we have to learn as our workloads migrate into containerized workloads, into the public cloud, and into Kubernetes environments. I think hopefully we all chose this as a career path because we like to learn, so I guess that's the good news. The other good news is whether your workloads are running containerized, they're running as a bare metal server in your on-prem data center, we're looking at the WAN, we're looking at the internet. Again, Kentik can observe all of that. And so in the same UI, you can go and look at that and visualize that in a way that you're used to thinking about it as a network engineer. Very focused on the network layer. How do we do this magic? eBPF. So eBPF stands for Extended Berkeley Packet Filter. And really what it is it's just, I call it a shim or a lightweight VM between the user space in Linux and the kernel space. So if you have a user space application that's running, let's just, say it's a web application, and it makes a system call down to the network layer to open up a socket, send a packet out on the wire. eBPF runs in between those two layers and can see that syscall, see that system call that requested that socket, and show you very similar pieces of information you would get out of, let's say, NetFlow or SFlow on a switch, right? What are the ports? What are the protocols? How many bits per second or packets per second did it transmit through the Linux kernel out onto the wire? And so that gives us as network engineers a lot of really interesting visualizations about the traffic that's flowing in and out of a Linux host. That's one option. But it also gives us some additional context and metadata that we couldn't even get off the top of rack switch. And I'll talk about that actually on the next slide here, where we get things like, what was the name of the process ID that made that syscall, right? What was the name of that process? what were the command line options that application was actually launched with, right? If it's running as a container, what was the name of the container that actually made that system call? Then we also get metrics we wouldn't get from traditional flow. So in an earlier presentation, I talked about the difference between passive monitoring and active monitoring. And one of the advantages of doing active monitoring, I said, I'm going to not contradict my previous statement, was that passive monitoring protocols historically have not given us packet loss, latency, and jitter, right? So they weren't really true performance of how the network is performing because they were just passively looking at the traffic that was actually on the network. Cool thing about eBPF is it changes that a little bit. We don't have to do active monitoring. We don't have to put traffic on the network. We don't have to run a synthetic test to be able to get that type of information. It's actually observing the traffic that's being that's flowing between the user space and the kernel space and going out onto the wire in the Linux server and giving us packet loss, retransmits, and latency. So we're getting the ability to solve problems or to see information with passive monitoring we've historically only ever been able to do with doing some sort of active monitoring, running a synthetic agent and running synthetic tests.
Jody here, quick question. Is that process running, that shim, is it running in user space or is it running as a kernel module?
Runs in the kernel, yeah.
With minimal impact on the kernel, that's the point.
Right, but you still need a container that has the ability to insert into the kernel. Okay,
yes.
Thank you.
And the good news is it doesn't. You don't have to like recompile your kernel, right? You don't have to write code directly into the kernel every time you want to make a change to that.
Right. It's just sometimes we don't have privileged access to do that with the kernel, in which case this is going to go kaboom.
Right.
Right.
Yep. Yeah. Visualize a container network gets a lot more complicated than just your spine leaf architecture or your 3-tier data center architecture, right? And that's one of the many use cases that we're trying to solve for here. All right, Kappa. So Kentik's approach to this is an agent that we call Kappa. So to Jody's question, this is our agent. This is our eBPF agent that runs in kernel space that gets us this information, sends into Kentik through our ingest, the data of what's talking to what, provides us some visualizations of what our traffic looks like. You can see the screenshot here from the product that shows the nodes in my, in this case, it looks like it's a AKS cluster, right? So in Azure, I've got a cluster running. I've got 4 nodes to my cluster. I can see the various clusters in that, or the various nodes in that cluster and what's talking to what. So I can see the volume of the traffic. I could dive down and see things like session latency, TCP retransmits between the various nodes in my cluster.
Are you tracking the packet rewrites that happen as well? And are you integrating with, for example, if you create a load balancer service and that traffic gets punted up to an ELB or an NLB, do you track that piece as well? And you track things like sidecar, container, or service mesh, all of those details that are more than just one pod talks to another pod.
Yeah, and that's the goal of being able to have, I'll say the holistic observability, right? Is to be able to stitch those pieces of information together, right? To see the end-to-end traffic flow, going through your various constructs, like you said, your ALB, your NLB, global load balancer, all those different pieces to be able to stitch that all together. Our Kappa agent can run in a bare metal Linux server. So if you just have a VM that's Linux based, you can deploy it as an agent there. Again, it'll run in kernel space, it'll grab that information. But the idea is then if we move into a Kubernetes cluster, we move into a containerized workload environment, then we have the ability to deploy it as a what's called a daemon set, so that it deploys itself on all the nodes. And as you add additional nodes, as you grow your cluster, it'll automatically get deployed out onto all the additional nodes. So you don't have to, every time you spin up one, go and install it manually. It kind of auto provisions as you as you grow your cluster and bring in more nodes. The other thing that it provides us, an advantage that it provides us in the Kubernetes infrastructure, is the ability to grab some metadata off the master node. So we can connect to the API, through the APIs to the master node, collect information about what are the workloads, what are the pod names, a lot of the information that we wouldn't necessarily get from the system call between user space and kernel space, we can get from the API and provide a lot more rich data. Unfortunately, we're out of time to do a demo on this today, but if you're interested in seeing a demo on this, feel free to reach out to me, either email, social media. I'm happy to, we can set up a demo. I can prove to you that it actually does exist beyond the screenshots that you've just seen here on the slides today.
Okay. Last question real quick, and this is getting into container networking. Maybe think of this. If I'm running an IPv6 only network, knowing that Kentik is a cloud service, where are you on that if I want to consume, the application and look at observability in an IPv6 only network? Is that possible today? And if not, is that, is that possible in the future?
Yeah, so you're wanting to send us data into our SaaS service over an IPv6, over the IPv6 internet, we'll call it. Is that what you're saying?
Not only communicate with the Kentik application over the IPv6 internet, but also looking at an IPv6 only network as far as the observability and analytics.
Yeah.
So in both cases.
Yeah, well, the answer to both is yes, right? So we have the ability to send data into our system over IPv6. We have the ability to actually access our UI, our SaaS UI over IPv6. And then also if you're running an IPv6 only network or even a dual stack network, we can actually show you visualizations by each protocol too. So break out how much of your traffic is V6, how much is V4, and visualize all that in the platform. So yes, the answer.